But it's a good time for us while we're standing in this hallway at this gorgeous hand sanitizer station. I'll show you some pictures of that in a minute. We wanted to catch up and talk about what's new with quantum computing in AWS. Because there's been some stuff happening.
In quantum, there's always some stuff happening.
Well, I'm going to make plenty of superposition jokes. Anyway,
please don't.
You are the general manager of Spooky Action at a Distance as a Service.
Amazon Bracket, the quantum computing service of AWS.
That's right. If you want to give it its formal name.
Well, so Bracket's all about enabling customers to get easier, start quantum computing easier, right?
Yeah.
And to explore the finer points of quantum computing. This is very much a research-intensive field. Customers want to understand how they can write algorithms that run on quantum computers. They want to exercise different types of quantum computers and see how they fit those algorithms.
How many different types have you got in Bracket right now? Because there's a lot.
So today we have a couple of superconducting quantum computers from companies called Rigetti and Oxford Quantum Circuits in the UK.
Yep.
We have an ion trap-based system from a company called IonQ. We have a photonics-based system from a company called Xanadu. And then just a couple of weeks ago, we launched a brand new machine from a company called Quera, which is an atom-based machine, neutral atoms, which is a very different type of machine. It's like an analog quantum computer almost. And it's particularly well suited to simulating quantum systems. So molecular behavior, for example, is one of the prime use cases for quantum computing.
Okay.
So very well suited to that. It's one of the first times that an atom-based quantum computer has been publicly accessible. So we're really excited to add that to the list. And there's more to come next year, but we'll talk about that then.
That's actually something that, I mean, you and I both understand Bracket and we sort of just move past. But for anybody who's not heard of it before, like one of its virtues is that anybody can get access to a multi-$100 million quantum computer that's sitting in some cryogenic lab somewhere.
All right.
Anybody can just basically walk up and get access to it through an API or a command line.
That's right. But that was always the goal with Bracket.
I know, but
before Bracket came along, you sort of had to know a physicist.
But I'm getting used to, yeah, that's right.
Or buy your way into some annual plan to use a
exactly right.
So we tried to democratize it. I mean, it's a sort of crazy word, but we use it to say we're fundamentally breaking down the barriers of exploring quantum computing and trying to figure out what's real. There's a lot of aspirational thinking in this market. Everybody wants it to happen really quickly because it's potentially transformative and disruptive technology. But it's a way away. There's a lot of fundamental research barriers to be broken down before we have a machine that can really tackle the big problems. But it's really important to start that journey now and to get up to speed with this technology, understand where it will apply, enable companies to build up the resources to go use it. So Bracket's all about knocking down the barriers, just getting hands-on, inventing algorithms, helping the industry in general build better machines, and just generally innovating collectively as an industry.
And potentially also pooling some of the knowledge that comes out of that, right? Because this is a collaboration point for people who are wanting to collaborate on their work on a quantum computer.
And that's always been the challenge. You have the hardware guys building the boxes, but you have the algorithmic specialists, completely different skill set. Then you have enterprises that are trying to figure it out, build up resources. You've got educators, you've got researchers, you've got governments trying to spin up national quantum hubs because it's a strategic technology. So a lot of very different, persona, if you like, that typically live in different universes. So Bracket, we think of Bracket as almost being a village square for quantum computing that enables these different groups to come together and just innovate. And our goal in all of this is just to try and move it faster.
Tell us about the algorithm library.
Yeah, so the algorithm library is just, is a way to get started more quickly. There's a set of well-known quantum computing algorithms. There's a lot of research papers coming out almost on a daily basis. So what we're doing is we're building them into pre-built code stacks that you can run simply and just get off the ground quicker. Essentially riding on the shoulders of giants. So when some publishes a paper, contribute it to the algorithm library, and others can build on that work. So that's important. The other thing we launched, again, just a couple of weeks ago, was what we call pulse control. So some people want to be right up in the stack. They want to abstract away from all the hardware, but some people really want to get into the machine, right? They actually want to start playing with the qubits, right? Twiddling the frequencies, literally, and the pulse durations of the things that actually make these qubits operate as a quantum computer. So one of the best ways to start investigating how to reduce errors. Errors is the bugbear. Faults in calculations, the bugbear of quantum computing right now. It's what's holding the industry back.
Yeah.
So understanding how you can really, really optimize at the chip level to deal with errors is all about managing pulse. It's not for everybody. It's pretty sophisticated, but for those that are focused on error mitigation in particular, error correction, it's an amazing tool. We just launched it. So now, for a couple of our machines, the superconducting machines, you can now go in and literally tweak the electronics on the circuit to suit your needs.
So any of these folks could come along, they could sign up to Bracket, they could pull an algorithm out of the algorithm library, they could be running it on a quantum machine within minutes or hours, right?
Yeah, spin up a notebook, you can run it on a simulator. Quantum machines, there's certain times of the day these machines are available. Simulators are 24/7, so you can, because we're still in the regime where you can simulate what a quantum computer does, they're not yet outperforming classical computers.
Yep.
So that's great because you can use simulators as a debugging tool. So you can practice on the algorithms, you can develop algorithms, run them, test them, optimize them on a simulator. Start with simulators, think about it as a journey. Free simulators living in our SDK. We have Bracket SDK to get you going.
Yep.
Manage simulators on the service, and then upgrade to using the quantum hardware. And like we said, there's a choice of different types of machines, very different characteristics, really different.
Yeah.
It's not. It really matters how you build these machines, and they vary by what you choose, how you choose to build your qubits, whether it's an ion or whether it's a superconducting circuit, whether it's an atom, or a photon. Single line of code changes between different devices, so you really can go test your algorithm on one machine, then go test it on another and see how it varies. Cloud credits for research, I said it just like you.
Yep.
Yeah, absolutely. If you've got a research proposal that you want to bring forward, then there's a web page, you can submit it.
Yep.
And we can fund access.
In fact, I'll put the address down the bottom of the screen for people who are watching right now. So
and we can we'll fund some or all of the work to actually access a quantum device and publish a paper. I mean, it's back to innovation, right? It's like you said about the flywheel. It's all about how do we get things connected and getting researchers off the ground. Researchers, often have tight budgets. These things are expensive.
And a lot of them, there is only one off, right?
Oftentimes there's only one single machine. And these, they require a fair amount of care and attention. These aren't devices you put in a basement. They are, often they are surrounded by people in white coats, for a reason.
Yeah.
So, they go through big, extensive calibration cycles. They live in refrigerators at, 13 millikelvin. Which takes a fair amount of maintenance. So yes, now's not the time to buy a quantum computer. I don't think now's the time to use one on demand on a service like Bracket.
Yep.
The reason why the credits program is important because researchers, are pushing the limits. They're not doing, basic educational work. I mean, sure, there are lots of universities running educational programs with simpler workloads, but researchers are pushing the limits, which means those are long-running experiments, and sometimes they need a helping hand to get over the cost.
If you learned something from this talk, then please consider giving us a like and subscribing to the channel so you can find out when more videos like this are available. And if there's an area you'd like to see us go deeper into, don't hesitate to reach out and let us know. See you next time.